We are in a new laboratory. It's called the Ground System Power and Energy Lab. It's a state-of-the-art facility. It's about 32,000 square feet. The centerpiece is a power and energy vehicle environmental lab. It has a series of dynamometers that allow us to simulate real load environments wherever the vehicle might go. So we focus in on ground vehicle development and engineering support, and this laboratory is going to help us enable greater energy efficiency in our vehicles and buy back some of that mobility performance that over time, as we've added capability, as we've learned new things, we have bought back that performance and added improvements to our capabilities so that our warfighters can be successful in their executing of their mission. What's unique about this lab is that we understand the environments. It tests a variety of things. For example, I mentioned the PEVL, or the Power and Energy Vehicle Environmental Lab. We can simulate Arctic conditions or the extreme desert conditions. We can operate in any mission profile or drive cycle, if you will, that they might encounter. And additionally, we have the remaining labs are around the piece. We have an energy storage lab that allows us to test the current batteries we have in the fleet, plus advanced chemistries where we try to push the envelope in terms of greater energy density so that we can make smaller packages, more power. We have a fuel cell lab in the back there where we work and partner with people like General Motors, Michigan State University, and what have you, to try to take that technology to the next step where it's applicable to our environments. So we can get something called silent watch, where we can turn the engine off, be stealthy, operate more safely for our warfighters. We also have an air filtration lab, which allows us to approximate the kinds of dust environments, anywhere from 0 to 4 times 0 visibility, which is pretty extreme. We also have a calorimeter. It's one of the largest vehicle calorimeters in the world, and allows us again to check out our cooling systems. For us, the big enemy is heat. You get heat from engines, you get heat from the environment, and all those things pull productivity from our power. So we want to understand those environments and come up with innovative solutions to buy back power, so we're not putting power against the vehicle thermal loading piece. Typically what will happen is we want to do our developments and get that equipment right before we send it out to the field. So this allows us to get it right as close as we can, reducing risk, understanding how that performs, and therefore make the tweaks here where it's cheaper, more efficient, more effective before we go out for record tests, and ultimately before we go down range and it's involved in a war fight where you have no room for error.